Alright, also this is your video for day 3 of 6.2. You should have or should be working on homework number 4. I would suggest doing homework number 4 before you watch this video because you have to be able to identify your U and do U substitution before you start doing definite integrals. So here, I gotta change one thing. We're going to learn to evaluate definite integrals today. I'm going to start you off with a warm-up. If you turn back to 6.2, day 2, this was the last question that you had in your packet. So I would like for you to try this problem and then press pause when you're done. Or sorry, press pause while you work and then press play when you are done the problem. So we are looking at the fact that there is a chain rule and a quotient rule, and this problem, it actually is a lot easier if you rewrite it as e to the negative x cubed, so that I'm bringing the e term back to the numerator and then multiply by x squared. If you didn't do that step, it might have been difficult to get the problem to work out. So if you see it this way, your u becomes negative x cubed. So du dx is equal to negative 3x squared. Dx is equal to du divided by negative 3x squared. And remember, we're looking to see if the variable term that was in our derivative is multiplied by dx, which it is, and that's how I know that this was going to work. Alright, so now we get the integral of e to the u times x squared, but dx is going to change to du divided by negative 3x squared. So the x squareds will cancel. The negative 3 I'm going to pull in front of the integral. And then e to the u du. So that just becomes negative 1/3. E to the u is just e to the u. U was negative x cubed, and then plus 3. And if you notice, none of the answers have negative exponents, so I'll have to change this. So I get negative 1 over e to the x cubed, don't forget my 3 down there, plus c. And so negative looks like c is your answer. Alright, so now we're going to do definite integrals, so you're going to turn to day 3. Definite integrals aren't too different. There is an extra step that I need you to do. And same thing, there are many other ways that you can do these problems. I'm going to ask you to stick with this method because of the way the AP questions are worded and created. So first thing we want to do, you've seen this problem before. You have to identify your u, and remember, secant squared x happens to be tangent x's derivative. So you want to use u to be tangent of x. If u is tangent of x, then du dx is equal to the secant squared x, which, remember, if I take my highlighter, my derivative needs to be multiplied by dx in the problem. So I'm going to ask that you just keep going and get kind of used to what you were supposed to do. The next thing would be to solve for dx, and that's what I'm going to do now. So I'm going to get du over secant squared x is equal to dx. So all these steps are going to be the same. You integrating the problem, still going to be the same. So here's the major difference, the whole reason I have to do an extra lesson. Right here, these values that you see in your integral, these right now are x values. Remember, we're going to change our whole entire question to be in terms of u. Well, that means I need to change my limits of integration to u values. So that means I'm going to have to find the u of, and I'm going to actually write them in, u of pi over 4, pi over 4 being the x value, is equal to tangent of pi over 4, which is 1. U of 0 would be the tangent of 0, which is 0. This is a u value, this is a u value. Those are actually our new limits. So how this works is down here in pink, we had our last step of writing our dx. I'm going to go through and just write what the integral would have been. So that would have been u to the 5th power secant squared x times du over secant squared x. And that takes care of my secant squared. And then over here, what I'm going to do is put the problem back together. My limits would have been lower limit of 0, upper limit of 1. So this u value that matches the pi over 4, that has to stay as the upper limit, and then the limit that matches the 0 has to stay as the lower limit. And then you get u to the 5th du. And so at this point, you are never going to look back at your x's again. I'm going to integrate this. 3-step integration. First thing I'm going to do, find the antiderivative. I'm going to find f of 1. And remember, 1 is a u value, and that works because I have a u sitting here. That'd be 1/6. F of 0 would be 0. 1/6 minus 0 would be the answer to this question, which means all the way up here, my integral value is 1/6. So let's do one more example. I think I'm going to skip around if needed. So this guy, same thing. I want you to start off by doing the problem how you're used to, identifying your u, and I can see that if I make my u x cubed plus 1, then my du dx would be 3x squared. And this one's actually absolutely perfect in terms of exactly what I have up here is exactly what's here, but I'm only going to focus on the x squared piece. That's all I needed, the x squared times dx. So, now going back, du over 3x squared is going to be equal to dx. I know that if I do the integration without the limits, I would have integral of 3x squared square root of u times du over 3x squared. And it's nice because the 3 even cancels. So I'm left with the integral of square root of u du. And then we just got to mess with our limits. We need our limits to be in terms of u. So u of 1 would be 1 cubed is 1 plus 1 is 2. U of negative 1 is negative 1 cubed is negative 1 plus 1 is 0. So my new problem, using my limits, would be the integral from 0 to 2 of the square root of u du. So antiderivative, that's u to the 1/2. That'd be 2/3 u to the 3/2. And so f of 2 would be 2/3 2 to the 3/2. F of 0 would just be 0. So the answer to this question would be subtracting those values, so 2/3. And if you want to figure out how to leave your answer, you actually would have to look at what answer choices are available. So if you notice that there's a square root symbol, then you would want to change this back to square root of 2 to the 3rd power, and then minus 0. So the minus 0 we're not going to write in our answer, but that would be one of the answers. It could be written a few different ways. So this is the reason why I make you do the problem that way. It's because sometimes you get substitution problems on the AP where they tell you what your u must be. So this isn't an option. You have to use the substitution that they're telling you. So u has to be x over 2. So what's really interesting is that I picked this problem because it's slightly harder than the substitution problems that you'll find in your textbook. So if you look at this one, first of all, the first thing you should do when they tell you what your u is, you should change your limit so that you don't forget about it. So u of 4, 4 divided by 2, u of 2, 2 divided by 2 is 1. So I know that the limits will be 1 to 2. And then the other thing, I'm going to come up here real quick. I get 1 minus, well, the u, then I know that this is u squared, over x, and then we're going to multiply by dx. So let me do that work down here. So the u was x over 2, du dx problem, you see this x? There's no x here to cancel that x. So that's why this problem is a little bit different. I'm going to show you it's still possible to do the problem. So, first of all, I do end up with the dx being 2 du. So here's that x that is still an issue. Well, the substitution that you have here, you can use this substitution any way you want to. So I'm actually going to solve for x so that I can get my u's to replace my x's. So what does that mean? I'm going to rewrite the problem to the left. The numerator stays the same. The denominator, my x is going to turn to 2u, and don't forget that the dx was 2 du. So my 2's will cancel, so this integral ends up being from 1 to 2 of 1 minus u squared all over u du. And let's see if we do have that. Well, first thing you can do is look through and just make sure your limits are correct. So all of these with the 2 to 4 are incorrect. So it looks like the answer is letter A. Rewind this one if you got a little confused. I want you to notice this green highlight, the fact that I knew I needed to eliminate that x, but the x wasn't there. The only reason this problem I know it's going to work is because they're telling you what your u has to be. So the problem will work out. We tend not to have to do full integration by substitution problems that are tricky like this. So I still want to show you a problem just because it has been on the past EP test. So I'll do maybe one or two more. I think I'll skip this one because we've done this integration before, cosine over sine or sine over cosine. I want to look at this guy right here. So in looking at trying to figure out what your u is, here's my inside multiplied by x plus 1. And what I want you to notice is if you took this guy's derivative, you would have 2x plus 2, which is actually just a multiple of this. So my u, I'm going to try out as the inside. So my du dx would be 2x plus 2, which is the same as 2 times x plus 1. So in terms of highlighting, my derivative term here matches this term multiplied by dx. So I end up with du over 2 times x plus 1 equals dx. My integral will be rewritten as, oopsie, I don't want to put 0 to 1. My integral will be rewritten as x plus 1 e to the u times dx, which is du over 2 times x plus 1. So this will cancel. I'm going to come over here. I'm going to change my limits. Past years, I always made students change the limits right at the beginning so that you don't forget to do it. It's probably a pretty good habit to have. So 0 to 3 of 1/2, and that's from this 2 right here. I put that out front. It's a denominator, e to the u du. So antiderivative would be 1/2 c. Actually, I'm going to show you how you deal with that 1/2, because the way that it happens, if I am integrating, I'm actually integrating this part. So e to the u, f of 3 would be e cubed, f of 0 would be e to the 0, which is 1. So the way that we deal with that 1/2 that's out front, you actually have to write the 1/2, and then f of b minus f of a is inside the parentheses. F of b minus f of a. Alright, so that looks like letter B. Alright, there are one or two more examples in here. You're welcome to play around with them before moving on, but most of these are same exact process. So to remind you of the process, once you identify your u, you're going to change your limits, whatever the upper limit is and the lower limit. And that's really the only difference. The rest of your steps, find your derivative, solve for dx, change your integration in terms of u's. Okay? So that's the major thing. So remember, when you have a DU problem, when you've changed your U substitution, this here has to be a U value and this has to be a U value. And we use this to get those values. All right, so your homework is numbers 4 and 5. I'm hoping that 4 was done already before you try homework number 5. That's due on Friday.